Welcome back to the workshop. Look at that, a semi-clean workbench, and I wanted to show you guys just in case you ever need to. This is the node right here, and if you've got this giant like 4090 card that you're playing with and it doesn't fit, use a dead hard drive to hold it up. That is absolutely the correct way to do things. Thumbs up. Alright, so let's move on. What has everyone been asking for? Yeah, we sold the 4060 again. Thank you to that viewer. Let's get on to what we really want to see and everyone's been dying to see. An AMD card. Alright, so this is a Radeon RX 7600 XT, 16 gigabytes. We cycled one of the 4060's money into this for the channel. We're going to check it out. There's the exact SKU and everything for you guys. Let's go ahead and get this box open. Take a look at this card, compare it in size since we've got a bunch of cards sitting off to the side here, and take a look at it. So here we go. We've got the box open. Oh, look, it's a quick setup guide. Yeah, we know what to do with those quick setup guides. A little bit of foam, and we've got the card. Much like the Intel, nothing else. Here's the card out of the protective case. Power plugs for you guys, just so you need to know. Let's take a look at the back plate if you're looking for design. This card's pretty big, 3 fans. Give you an idea, like up next to, that's a 4090, so yeah, 4090 is always going to be bigger. This is that Intel Arc A770. About the same size, really. And 4060 Ti, much bigger than a 4060 Ti. Let's go ahead and take this card, get it into this GPU bench node, and see if we can put it under some tests. Alright, new mess. There we go, just to give you a better size, there's the Intel Arc, there's a 4070 Super, and then on top up here, we have that 7600 XT. See you guys in the lab here in just a second. Yeah, coffee. The liquid that helps you fight procrastination and clear your brain first thing in the morning so that you can get on with some fun in the lab. Welcome back to the lab, everyone. Today we just unboxed that 7600 XT 16 gigabyte, and I know everyone's screaming, let's take it through the leaderboard, let's take it through the leaderboard. Okay, I thought we'd do something a little bit different today, and there is a lot of work that ends up going in behind the scenes before I ever even show you guys a leaderboard test. Normally that involves either me doing some coding with my friendly robot over here to make the testing platform work for that specific card, or different backends if I have to switch from local AI to Llama CPP or whatever it may be to make a specific card work. Get the reporting off of it, and then we also need to get metrics out of it. And even more importantly, that I've learned, especially after that Intel Arc A770 that we just went through a fight on, and you haven't seen the last of that card, but we're going to explain in here why I chose this very specific 7600 XT Gaming OC 16 gigabyte graphics card. And you guys want to know what that reason why? It's because it was on sale for like $2.99 when I went to go buy the card. Yeah, that's the only reason why. So a lot of us are like that. We would go out there and look at it, kind of do our research, but then it's like, okay, hey, it's really on sale. I'm going to just go ahead and buy that. We recently sold another 4060 Ti 16 gig to another viewer. Hope you feel like you got a good deal, but you guys can all thank that viewer for reaching out to me, purchasing one of those 4060 Ti's, as I just turned around and cycled that money right into this card for the community. And we're going to kind of run this thing through some tests today. But we're going to talk about those tests and the reasons why I'm going to do this behind the scenes with you guys before we ever even take this card through the leaderboard. So most of us are looking at this card. Let's go take a look at the specs of this, right? So this is a fairly new card. It was released just this year. Has 16 gigabytes of GDDR6, 128-bit memory bus, supposable bandwidth of 288 gigabits per second, and a TDP of about 190 watts. We would expect it to be able to support ROCm. Again, just my natural assumption, just like I did with that Intel Arc A770 card with SIL, that ROCm might be the most performant for this card. But I'm going to go ahead and point out something to you guys, which you always should do if you're trying to build this system, which I did not, so learn from my mistakes. I did not look up the system requirements on ROCm. I figured that this 7600 XT was 16 gigabytes and ROCm would fully support it. Do you guys see something missing from this list? Yeah, the only Radeons that ROCm supports out of the box is basically the 7900 series. So I ran into a little bit of problems to get this running. Luckily, you can actually get around this, and we will cycle over to this GitHub issue on ROCm about 7600 XT support, which they do not. They don't fully support this yet. But if you come down here, you can actually find that there's this nice little environment variable that basically sets it back to 11.0.0, and then you can use ROCm with these cards, and probably a lot of other cards that are in unsupported mode. All right, but this is fine. So I got that working with Llama CP and local AI, just like we test all of our NVIDIA cards wonderfully, right? It was working just fine. But then it concerned me that this was a much newer card and we're setting it backwards, and there might be some issues with that when it comes back down to drivers, ROCm, other concerns in there about like what Llama CPP is compiled on, and then local AI on top of that, and wondering if we were going to end up having issues from that. Now, the subject of Vulkan also came up, especially when we were talking about the Intel Arc A770 and what we were seeing out of using SIL from the back end. So as part of what I do before I even run things through is we have to go look at these different backends and actually compare them. So that's actually what we're going to do today, is we're going to just wing this as a behind the scenes test. I'm going to take you guys through basically what I kind of flush out. And in this specific one, we are literally going to take ROCm versus Vulkan and see what the difference is with this Radeon 7600 XT. So let's go ahead and get right into that, right? So let's flip over to, I have an AMD based one that we can actually flip the images on, so we can either use ROCm or we can use Vulkan. Let's go ahead and start off with ROCm and just see, again, because my assumptions are always going to be that ROCm would run the best on the AMD cards, but we'll find out. Let's go find this out. So let's go ahead and start out with a decent sized model or a quant, and we'll just run Q8. This is a 16 gigabyte card. We're not going to flush out everything for the entire leaderboard or anything. We're just going to do some basic comparisons in between ROCm and Vulkan and see which one we should be using to run this card for the leaderboard tests. So we're actually right now set up with ROCm. I can tell that because it's returning the GPU information from ROCm info here for me. We should be all fresh and started, so let's do the Q8 model. We're just going to run, let's go ahead and just run 10 tests. Give it a good run and see what's up with that. And we'll just call this 7600 XT Q8 ROCm. And you guys will get a first initial look at how this specific consumer grade $300 AMD Radeon actually performs with ROCm. Over off to the right, this is AMD GPU top. It is running basically so that we can get an idea for all the sensors of power, clock speed, the memory usage, and the normal details that we like to see on all of these cards. But we'll get a general look at that. So again, this is Q8 on the 7600 XT 16 gigabyte using ROCm as a backend. Let's go ahead and get this started. I'll pop this side menu out of the way. Using just over 10 gigabytes of VRAM right now. We can see the GPU power cranking up there. 177, 79, 175, so mid to high 170s it looks like. The first one on ROCm came back at 27.5 tokens per second. Let me just jot that down, Q8. But remember, we always don't pay attention to the first ones. That's why we run at least like 10 to 20 tests, or 20 tests in the case of the leaderboard, just to see where things try to settle out to. Second one back at 27.14. Let me pop this into a little bit of a fast forward mode for you guys. I'll bring you back for the 10th test, and then we'll kind of take a look at where that landed. Flip over and run the same exact test with Vulcan and see where that landed. That one fell down to 24.6. All right, quick fast forward. Come back when it's done. All right, I'm going to let you guys watch this last, or the 10th test for this report. And I want to point out that if you look at those results above, it's slowly gone downhill, and we're tracking at about 9.2 evaluation tokens per second. Now, this is a pattern that I saw in my just base initial testing before. I was like, okay, I'm going to go ahead and record all of this as a behind the scenes and let you guys check this out. So I was watching this test looking, going, saying, well, maybe the GPU is thermal throttling itself, but I've been watching and it is definitely not doing that. Not downgrading the clock speed, temperatures look fine, and it's cruising at the same, judging by the metrics, it's cruising at the same as it was at the very first test. That was 27.5 tokens per second. So this is some of the stuff that I'm always interested in seeing before I ever sit down and run through the hours of full test for any graphics card. So I would consider this to be a very interesting performance profile, maybe even one that we haven't seen on the channel just yet. And also I feel like we're going to have to run back-to-back tests in between ROCm and Vulcan and see how it goes. So let's look, see, if you just paying attention to the numbers, we have ended up at 8.3, 9.2, 10, 11.9, 14.0, 17. That's interesting. This is the same hardware that we've used for testing all of our other GPUs. Same backends, right? Local AI, Llama CPP. First time we've used ROCm, and first time we've had one of these AMD Radeon cards, let alone, remember, an unsupported 7600 XT running on ROCm. Interesting report. So let's go ahead and produce that report. Let me grab the name off of it real quick. And I'm going to go ahead and cycle this pod, and we're going to run one more test with ROCm, just because I'm curious, especially after the Intel Arc series that we were playing with. And this time, what I want to do is actually run the full FP16, so that we're not running a quantized version, because some cards and some software just simply perform a lot better with straight out FP16. So we're going to do this same exact thing. we're going to change this to say FP16. And then we're going to run that same exact 10 tests that we just did, but at FP16 and see how it performs there so that we can compare that to Vulkan. Let's go ahead and get this started. Filling up the VRAM up there. Ooh, yep. Just over 15.5 gigabytes of VRAM being used for the FP16 model. Looks like it's moving pretty decently to start though, but we'll see if it has that same profile that we saw, and you guys will see it in the graphs when we pull up the reports here at the end. Again, about mid 170 to high 170-ish wattage, if you guys are paying attention to that for power usage. Those look to be moving pretty decently. 15.19 for the first one. $300 AMD 7600 XT, guys. I'm not expecting this thing to be like setting the world on fire, but definitely do some decent results with any luck. Still holding temperature, still mid to high 170-ish wattage. 15.192. Let's go ahead and fast forward a bit. I'll come back at the end of the FP16 test and let you guys feel that and see where we ended up. And then we'll go run these same exact tests, Q8 and FP16, using Vulcan backend and see how that turns out, so that maybe we can decide which backend we should be using to run this AMD card through the actual Mistral leaderboard test. All right, and that was the last test on FP16. Not bad, settled out to about 12.14. It was still slightly going down, but not nearly as downhill as the quant version. Okay, so let's go ahead and generate that report. Grab that model name, or the report name. And then what we're actually going to do is we're going to reset up, but we're going to be using the Vulkan based image. So I'm going to patch that image. And we'll know it's Vulkan because it shouldn't come back with any GPU, because I haven't set up the application test to be able to read anything with Vulkan yet. So let's go ahead and we'll cycle it just to make sure we're all clear. Alright, let's switch back over and do the Q8 model first. Change this initial report name. Vulcan. Let's go ahead and just close out the sidebar and get this started. So this is Q8, same exact card, using the Vulkan backend. Don't worry, it will use the GPU. You guys will see that. Now let's take a look and see how Vulkan performs on a quantized version and then FP16. And then we'll pull up the graphs and look at these, and then we'll see if we can decide which backend we should be using to run the AMD card, or at least this specific one, through the Mistral leaderboard test. And if you guys have thoughts on that after you see the reports, please comment down below. Let us know, especially if you feel like there's tweaks that we're missing to make this better. So, first one back at 20 which is slower than where ROCm started out. And yes, we have to call it ROCm. Come on, guys, ROCm sock'em. But still way higher than where the Q8 ended up. So let's go ahead and kick this into fast forward mode. We'll come back for the last one for Q8 on Vulkan and see if it held a little bit more steady. And this is the last test on Q8 using Vulkan on this RX 7600 XT. And I still saw it using about the same wattage, 160 to 170s, upper, even hitting 180 or so at peaks. And finishing out at about 13.13, which is interesting and above ROCm. All right. Okay, so let's go ahead and produce this report. Let me grab the name and we'll flip over and we'll do FP16 and then we'll bring these up in a graphical view so that we can compare the different profiles of ROCm versus Vulkan on this exact same card and exact same hardware back to back. So let's go ahead and cycle the pod. And we're going to choose the FP16 to run that back to back here. Change up our report name, FP16. And let's get FP16 started on Vulkan here. Get the sidebar out of the way. You can see it loading up using just over 15 gigabytes of VRAM. Doesn't look too bad to me at all. Let's see where this finishes out. At least for this first test here. This is full FP16 on this 7600 XT. First one back at 10.5 evaluation tokens per second. Okay, let's kick it into a little bit of fast forward. We'll come back at the end here, see where that fell, and then we'll put all of these reports together and take a look, see if we can make a decision on Vulkan versus ROCm. Alright, coming up on the end of the Vulkan FP16 run on this 7600 XT. It looks to have cut its speed down by half on the FP16, so I was seeing about 5 tokens per second. But we'll see where this finally comes out, and we'll put this all in graphical reports and take a look at it. I can tell you guys from running a ton of tests, not only that you've seen on the channel, but off the channel and for my own good, which is where this channel was born from. There's going to be some interesting performance profiles from these two different backends that I think is going to make these tests well worth showing to you guys. And then we'll see if we can actually make a decision from this. But this is why we test hardware, and apparently not just hardware, but also, you know, really back ends if we have to get the best one. So let's go ahead and produce this report. That last one came back at 5.3 tokens per second. And then what we're going to do is we're going to take those 4 reports that we just put together and add them all into one. So there's Q8 of ROCm, FP16 of ROCm, Q8 of Vulcan, and FP16 of Vulcan. We'll call this ROCm versus Vulcan. Combine files, and let's go take a look at this. ROCm versus Vulcan. Let's expand this out so that you guys can see this quite a bit better. Alright, in red we have the FP16 for Vulcan. In green we have the Q8 for Vulcan. The orange is FP16 for ROCm, and the Q8 is blue. This is the prompt evaluation time. So this is basically how long it's taking to analyze. So let's go ahead and move over to the evaluation time. FP16 on the Vulcan definitely taking the longest. Q8s are basically the same. Okay. Total time should be those put together. Prompt tokens evaluated 111 across all of the tests. Completion tokens, this is going to mimic the length of the response, not the accuracy, again, just the length of the responses, which is fairly similar across FP16 and Q8 across the board there. Total tokens is going to be those two put together. Prompt tokens per second. So we can see that the FP16 from ROCm and Vulcan fell to similar levels. The Q8 from Vulcan was under the Q8 from ROCm there. Okay. Interesting. Interesting. Let's hop over to evaluation tokens per second, because this is what everyone is going to be looking for here, right, as we compare. But I also want to point out different things when I consider performance profiles that would definitely show up in longer tests like that we do for the leaderboard. We saw, say, like the Mac hardware or even the Intel Arc that we just recently tested. They basically are flat lines across the board, right? So that's ends up being very predictable performance if it's flatlining out. The NVIDIA cards, most of them that we test, they'll start out pretty fast and then they'll slow down just a little bit and then they'll plateau. And then that plateau is very good for you to take averages off for decent performance profiles. Here's the thing that I'm noticing with ROCm right off the bat, at least with the quantized models, right? So the Q8 starts very fast and kind of falls off a cliff very quickly over the runs of the tests, all the way down to hit about 8 tokens per second when it started out at 27.5. These tests that we ran today don't seem to be long enough to see if this actually plateaus out, but if you look, it doesn't look like it's plateauing out. It looks like it's just slowly crawling to a halt. Now, we can almost see slightly the same pattern with the FP16 of Vulcan, but on FP16 models, I tend to see this happen, and this was smoothing out a little bit where it looks like it was about to plateau around the 5 token per second range. What next is interesting is if we take a look at the Q8 for ROCm, right, in blue, and the Q8 from Vulcan in green, That is a clear performance profile difference. And the Vulcan was not only running the quantized version decently faster, but also looked like it was about to plateau out. Same thing with the FP16 on ROCm. That one actually held quite a decent profile. Started at 15 and was smoothing out at about 12 tokens per second, but clearly beating out FP16 on Vulkan. So in this case, the quantized models are actually looking to run quite a bit better through Vulkan, and the FP16 model looks like it's running quite a bit better through ROCm. Interesting. All right, so what I would like to hear from you guys is what you saw here, what you learned from just these basic tests behind the scenes before we ever take this thing through the leaderboard whatsoever, and then comment down below what you think we should use as a backend for running this specific AMD card through the Mistral leaderboard based on what you're seeing here. Also, if you have any questions, comments, or suggestions on how to tune Vulkan or ROCm better for this card, spit it out, let me know. I'd be happy to retest this thing. I also think that we're going to need to revisit the Intel cards, especially with Vulkan after we're seeing these type of results. I hope you guys enjoyed this behind the scenes look into what we do before we ever put those cards out through the Mistral leaderboards. And this one's very interesting, ROCm versus Vulkan. Tell me what you guys see in this data. Until next time, get your AI to pizza. It helps us to figure out these things.